Good morning everyone. Today we will discuss about DSP, which is digital signal processing. It is being used for widely applications. The applications of DSP are audio signal processing, digital image processing, video processing, speech processing and recognition, digital communication, and biomedical signal processing. And lastly, the brain computer information, which is BCI. So from those applications we can say that digital signal processing is very important in our daily life. Now, why the signal needs to be processed? Signals are carriers of information. Those can be useful and also can be unwanted. From the signal processing we can get the useful inputs and we can distract the unwanted signals. In here we can extracting, enhancing, sorting and transmitting the useful information with the help of DSP. How the signals are being processed? Those signals are being processed by the analog signal processing and digital signal processing. In this lecture we will discuss about digital signal processing only, and we will have a short idea about analog signal processing. Now move to the next. Here this is a diagram of digital signal processing, which is DSP. In this section, first of all we have the analog signal. In that case we have xt, which denotes the analog signal, which have in this analog signal we have time, which is continuous. From the anti-aliasing projection we moved from low to high pass and then transform it into ADC, which is analog to digital converter, by sampling, quantization and coding. In digital signal we get the DSP, which is digital signal processing. From that we can have the digital signal output, and lastly we have the DAC, which is digital to analog converter, and from this we can lastly post filter that and get a recovered analog signal. Now we are in the signal basics. First of all we need to know what is signal. A signal is a function that represents the variation of physical quantities with respect to any parameters, such as independent quantities like as time, distance, space, temperature, etc. It means that signal is just a function that represents various of physical components. In this section we can have that ft, which is a function, and in that we have omega and t. When we change the t or the omega, the value of the function will be changed, which is the basic idea of signal. That's why we say that any parameters like as time, distance, space and temperature, which can convey the information as a variation of physical quantity. This is the diagram of a signal. Here we have time and voltage. By the changing value of time, the voltage is also changing in the range of plus 120 to minus 120. In this section, the x-axis used for independent quantity and y-axis is for the dependent quantity. Now the function. A function is a relation between a set of inputs and a set of outputs. A function relates an input to an output. It is like a machine that has an input and also give us an output, and the next output is related somehow to the input. As in the example we have see that f of x equals to x square. Here we have an input which is value x, and we can get the output as x square. So that's why we can say that it will work as a function. That's for today. Thank you.